So today we will look at the Millikan's oil drop experiment. So basically Millikan was a scientist and which he actually did an experiment in order to find the charge on the electron, and this experiment is also known as Millikan's oil drop experiment because he used oil. Okay, now let's understand the setup, that what kind of instruments did he use and what was the actual setup. So as you can see over here, there is a box, okay, and this is the one stage and this is second stage. Basically this is a metallic chamber and he fitted two electrodes over here. This is first electrode, which is known as A, and this is A apostrophe. This is another electrode. Okay, so what he did first, in the first partition, in the first chamber, there was a hole and which was connected with a spray, and the spray is known as atomizer. Okay, actually this spray contained the droplets of oil. It contained oil basically. So why it is known as atomizer? Because when we spray the oil, the size of the oil is like atoms. They are quite small, so that's why they are known. This instrument is known as atomizer. So when he sprayed the oil on the first chamber, so as you can see over here, there is a hole. He did a hole over here, and the oil from the first chamber went into the second chamber, into the second one. As you can see over here, that he connected a telescope in order to see that what's happening inside the metallic chamber, what is happening, where the oil drops are going, to observe what is happening. So he connected this metallic chamber with a telescope in order to observe, in order to see. So as you can see over here, there's another hole. By this hole he passed X-rays to ionize the air particles or gas particles. As you can see that the second chamber, okay, the pressure in this was adjusted by the vacuum pump, and over here there were the many air particles in it. So what happened actually, when he passed X-rays from the second metallic chamber, the X-rays ionized the gas particles, the air particles, like as you can see over here. When the X-ray hit the air particles, the electron move out. Okay, so now what was the velocity when we didn't connected it to the battery electric field? As you can see over here, before electric current, V1, which is the velocity of the oil drop before the electric current, is directly proportional to the mg. Okay, what is mg? As we know, weight is equal to mg. Weight is the weight of the oil drop. Obviously gravity is there, so the oil drop will come downward. So the velocity of the oil drop before the electric current depends upon the weight, which is weight is equal to mg. So what happened when we connected the electrodes with battery? So what happened, it became positive and it became negative. These are electrodes, positive and negative. This is now anode, this is the cathode. Okay, now look at this again. When the X-ray hit the air particle and the electron knock off the atom, so the electron joined with the oil drop, and so the oil drop become negative. It became negative. So as you can see over here, if the oil particle is negative over here, where it will go? Like there it is positive electrode and this is negative, so the negative will repel, but the positive and negative will obviously attract, so it will go upward. But don't forget that there is another force, there is another weight, which is the weight. The gravity is attracting the oil droplet towards itself, towards the downward. So there will be a point when the electric force will be equal to the gravitational force. Basically the oil droplet will be in the mid, like gravity will also be attracting it, and the electrode will also be attracting it. So if you want to see the actual velocity, what is the velocity of the oil drop when we connect electric field, so as you can see over here, V2 is directly proportional to E2 minus mg, because as you can see electric field is more powerful than the gravitational field. So E2 minus mg, then whatever will be left will be the velocity of the oil drop after the electric current. So as when we divide them, when we compare them, V1 is equal to V2 and is equal to mg upon E2 minus mg. So velocity can be easily determined by observing the oil drops from the telescope. As you can see that we have connected here telescope in order to observe that what's happening inside the metallic chamber. So we can easily find, and G and E both are constant. So basically we have to find the charge. First of all we will find the charge of the electron, then we will find the mass of the electron.